quadratic inequality with one variable. Let us have an example. Find the solution set of quadratic inequality x squared plus 4x minus 21 is less than or equal to 0. Step 1. Find the values of x of the given inequality. First, we will write again the given inequality x squared plus 4x minus 21 is less than or equal to 0. Let us write the given inequality into its equation form. So, it becomes x squared plus 4x minus 21 is equal to 0. Factor the given equation. The factor of the given equation is x plus 7, multiplied by x minus 3, which is equal to 0. Apply the zero product property. We equate each factor to 0. Then, we have x plus 7, which is equal to 0. And the other factor, x minus 3 is equal to 0. Then, solve for the value of x in each factor. So, we have x is equal to positive 7 is equal to 0. I transposed positive 7 to the other side of the equation. Then, it turns to negative 7. So, we have x is equal to negative 7. For the other factor, we have a negative 3, which is equal to 0. Transposed negative 3 to the other side of the equation. Then, it turns into a positive 3. So, we have x is equal to positive 3. Therefore, the value of x is equal to negative 7 and positive 3. Step 2. Plot the values of x in a number line. We need to draw a number line. From the right side are the positive numbers and on the left side are the negative numbers. There you go. Then, let us plot the values of x that we get earlier, which are negative 7 and positive 3. There it is. Step 3. Assign the first, second, and third intervals for testing the value. So, from negative 7 to negative infinity, it will serve as the first interval. The numbers between negative 7 to positive 3. This will serve as a second interval. And lastly, the number greater than positive 3 to the positive infinity, will be served as the third interval. Step 4. Test one value of x in each interval, and also the points between the intervals. From the first interval choose any number as a value of x. I chose negative 8 for the first interval. Let x be equal to negative 8. Get the given inequality, which is x squared plus 4x minus 21 is less than or equal to 0. Then, substitute the value of x, which is negative 8. So, we have negative 8 squared plus 4, substitute the value of x, which is negative 8, minus 21, is less than or equal to 0. Next, let us simplify each term. So, we have negative 8 squares, which is equal to positive 64. Positive 4 times negative 8 is equal to negative 32. Minus 21 is less than or equal to 0. Then, we have 64 minus 32, which is equal to 32, minus 21, which is less than or equal to 0. 32 minus 21, which is equal to 11. Less than or equal to 0. Is 11 is less than or equal to 0? The answer is false. Therefore, on the number line, all the numbers from first interval are not solutions to the given inequality. Since they are not solutions to the given inequality, we will not shade the number line less than negative 7 towards the negative infinity. Next, let us move to the second interval. We will use any number between negative 7 and positive 3. To make it easier to solve, I will choose 0 as a value of x. You can try the other number if you want, as long as the number is between negative 7 and positive 3. But, for now, I will use 0. So let x be equal to 0. We will repeat the process just as we did earlier. We substitute the value of x and then simplify, until we reach the desired result. The result is negative 21. Is negative 21 less than or equal to 0? The answer is true. On the number line, the numbers between negative 7 and positive 3 are solutions to the given inequality. Therefore, the region in the second interval will be shaded. Next, let us move now to the third interval. Choose any number to represent the value of x. I will choose 4. Remember, in choosing the number, it should be in the range of the third interval. So, 4 is in the range of the third interval. Let x be equal to 4. We will repeat the process just as we did earlier in the past two solutions until we achieve the result. The result is 11. Is 11 less than or equal to 0? The answer is false. Therefore, the third interval is a not solution set of the given inequality. The region of the third interval will not be shaded. We are already done with the intervals. Now let us also test the 2 points which are -7 and +3, if they are also a solution to the given inequality. Let's start with -7. Let x be the -7. We will undergo the same process just like we have done in the previous solutions. We substitute the value of x, which is -7, until we get the result. The result is 0. Is 0 is less than or equal to 0? The answer is true. Therefore, on the number line, the point -7 will be shaded, indicating that it is also a solution to the given inequality. Next, let us move to the second point, which is +3. Let x be the +3. We will undergo the same process just like we have done in the previous 4 solutions. We substitute the value of x until we reach a result. The result is 0. Is 0 is less than or equal to 0? The answer is true. Therefore, on the number line, the point will be shaded, just as we have done earlier, indicating that it is also a solution to the given inequality. Step 5. Write the solution set of quadratic inequality in interval form. The solution set of the given quadratic inequality is x is less than or equal to +3 but greater than or equal to -7. That is the solution set of quadratic inequality, x squared plus 4x minus 21 is less than and equal to 0.
For more videos on mathematics, please don't forget to subscribe.